Good morning. The last 3 to 4 hours we have been discussing about the electric field, and in that we have introduced only for two things like discrete charges, the case of point charge and also the case of dipole, right? And also after that we have seen the case of again uniform electric field and a charge is placed inside, and similarly the cases of a dipole placed in uniform external electric field, and some important discussions were made. Now, today's session will have some examples based on all our understanding regarding field. Right. So one more time, when I say numerical examples, please first keep your calculators aside. Don't use your calculators. Be ready with your pen and paper. Simplifications or calculations, let it be from your side, right? First example, one of the examples I said, right? Find intensity of electric field at a point -2, 1, 4, and I have taken this in meters, right? Due to a point charge of 3 microcoulomb placed at Q -2, 0, 3 meter. Right? We'll do it in both ways. First scalar form and also in vector form. In both ways we'll do this example. Right? Now here, when you read the question, basically you see that this is 3 microcoulomb. Nothing is mentioned with any sign. Therefore we'll consider that as a point charge. Now, always I tell you, whenever you are doing examples, the first thing is that the data to be converted into symbols is step 1. In fact, most of the work will be done. Once you read the data, please convert the data into symbols. Which symbols? The symbols in the form of which we have studied a concept or we have derived one expression. Is it not? Likewise. So for all this thing, I am now writing this data. Given data says this charge Q is 3 into 10 rise -6 coulomb. Now when it is the case of numericals, substitution, the most essential thing is about units. Most of the students, they actually find it difficulty with the units itself. Therefore there is no next level. Whenever you are using the data, please, as much as possible, almost every time, please use SI units. Now here he says that 3 microcoulomb, therefore I will write as 3 into 10 power -6. This should not be forgotten, right? This is the charge that is given. Now you see what is the distance. Distance R is equal to, now this is what is placed at Q. Charge is placed at Q and we are finding the intensity at this point. Therefore, R is nothing but mod QP bar. Is that okay? QP bar. Mod QP bar. This is what is the distance between the two charges I am taking. This is, yes, how much? Now once again, how to write this vector and then the magnitude. Distance between 2 points. How to write the distance between 2 points? Yes? Root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Now that comes here, right? Therefore, first let me write the vector and then I will write the magnitude. Yes, distance between charges. I am writing first the vector r bar is equal to. Now here comes everything. How to write that r bar vector is essential. Now for that please see here. Suppose this is the point Q where we have placed this charge of +3 microcoulomb. The point P is -2, 1, somewhere it is there. So this is what is the point P. Now look at this. The given charge is positive charge. When it is the vector, we have taken electric field. Electric field is always a vector along the line joining. Due to point charge, you remember? Along the line joining, if it is positive charge, away from positive charge, towards negative charge, that is to be used here. Therefore, if this is what is the line joining Yes, for the point P, this is the vector that you will write. This is what is E bar, the electric field. Electric field. Now look at this vector, whether you call it QB bar or PQ bar. Yes, this is what is Q, where we have placed the charge which is positive and finding the intensity at P away. Therefore, this R bar vector is now, yes, QP bar. This is what is QP bar. So this is initial point and this is final point. How to write a vector? Final minus initial. Therefore, final minus initial means, yes, minus 2, minus of minus. Shall I write all that? No, I don't write. You will do it. Minus 2, minus of minus 2 becomes 0. Therefore, this is 0 I cap. Next, I will write plus. Y2 minus Y1. Y2 minus Y1. Y1 is 0. Y2 is Y1. Therefore, this is 1 minus 0. Therefore, this is J cap. Next, plus 4 minus 3. Z2 minus Z1. 4 minus 3. This will come as again 1. Therefore, this is 0I plus J plus K. Right? Therefore, I will write it as J bar, J cap plus K cap. J cap plus K cap. Right? Now what is the magnitude? How to write the magnitude for a vector? Root of x square plus y square plus z square. Therefore now R is equal to root of 1 square plus 1 square, that is root 2 meter. Root 2 meters. Therefore now find the velocity, find the intensity. Intensity vector E is equal to, yes, remember, K Q by R square. If you want it as a scalar, then substitution 9 into 10 raised 9, the value of K 1 by 4 pi epsilon naught. Q value, yes, it is 3 into 10 raised minus 6 by, what is R square? You will get it as 2. R square, you will get it as 2. This becomes 1.5. 1.5 into 9. 15 9 is 135. If 9 into 1.5 becomes 13.5. So this is 13.5 into 10 cube. 13.5 into 10 cube. Now comes all important thing, unit. Don't ever forget these units. Right? We are finding the intensity. SI unit of intensity is Newton per Coulomb. Also we have given the other unit as volt per meter. Therefore this is 13.5. Yes, I will write it as Newton per Coulomb. You can write, or volt per meter you will write. This 10 power 3 is what is called as kilo. You remember all these multiples, sub-multiples? We have been using it for about 1 year. Therefore this 10 power 3 I will call it as kilo. Therefore I will write it as kilovolt per meter. Kilovolt per meter. Otherwise, yes, Newton per Coulomb. Sorry, you have 10 raised 3, right? 10 raised 3. Therefore I will write it as Newton per Coulomb, or this is kilovolt per meter. So this is what is our answer in the form of scalar. We have given all this as in the scalar form, only the magnitude, right? Actually, I wanted to do it completely in the vector form, right? Now, when you got this answer, simply multiplication and division, nothing more than that. Remember, all your 5 marks problems for board examinations, they are simply addition, subtraction, multiplication, division. When you read the data, what is that particular concept that is asked and what is that simple expression that you will use? Okay, recollecting them and simple substitution, 5 marks. Now let me do the same example in terms of vector form. You remember what is that vector form we have given? E bar is equal to KQ, yes, by R cubed. KQ by R cubed times R cap we have given. You remember that? Or else or else the same expression k cube by r square times r bar which is already ready with us. Therefore now substitution e bar. Now this entire term in the brackets is what is the magnitude term, which of course already we have just now calculated. One more time you do that, right? So this is how much you got? 13.5 into 10 cube you got it as times what is r bar? This is what is, yes, j cap plus k cap. J cap plus k cap. So yeah, j cap plus k cap. So this will be the vector form. In the vector form, if you remember, what is important is in writing this r bar vector. How to write that r bar vector all depends upon the charge that is given. If it is positive charge or negative charge, that is how we have done. If you want, finally of course for this entire solution, we have told this is what is the charge of 3 microcoulomb, which is positive, and somewhere over here this is what is point P, right? Therefore now this is the line joining and it is away. Therefore the vector is r bar q p bar. That is what is substituted, right? So this is what is one simple example based on our understanding of electric field point charge. Electric field and point charge. Now you look at this next example. Next example I have given you a case of 2 point charges. 2 point charges. Yes. Supposing this is the example that is said. Find intensity of electric field at the midpoint of 2 point charges given to be 5 nanocoulomb and minus 10 nanocoulomb, 12 centimeter apart. Nothing is said, means we take it for granted that it is air is the medium or vacuum is the medium. What is the example? 2 point charges. 2 point charges, separation is 12 centimeter. Now first, all such kind of things we will make use of a simple figure. Now once I draw that figure, most of the solution will become so easy. How? First show that the data as the 2 point charges are, one is Q1 given to be 5 nanocoulomb. Remember here the multiple is 10 raised minus 9. Q1, the other point charge is, yes, other point charge Q2 given to be, yes, and most important is the sign. He says minus 10 nanocoulomb and the distance between them is 10 centimeter, he says. Now this is what is the midpoint. If r is the distance between the two charges, then I will write it as r by 2 and this is what is r by 2, right? This is what is the point of observation and write it as P, where we need to find the intensity of the electric field. Right. First, you see at the point P, why intensity arises? Because P is a point which is at a distance r by 2 from Q1. Therefore, now I am writing at P. At P. Now, this is the time, again, I am using the concept of our electric field as a vector, right? And this is very important thing. You just please follow line by line. No, afterwards you should not say I have missed that line, right? Because that makes big difference in the final answer. At this point P, at this point P, right? This is what is Q1, which is positive charge. Therefore, electric field is away from positive charge. This is what is E1 due to Q1. E1 due to Q1. If you call, let us give the names. This is the point A and suppose this is the point B, the 2-point charges, the 2-point charges at A and B, and we are finding the net intensity at P, the midpoint. We have told this is E1 due to Q1, and this is the second charge Q2 is going to be the negative charge here, you see. And now suppose if I say E2 is the electric field due to Q2, look at this negative sign. We said the vector is always away from positive charge towards negative charge. Therefore, now here I am writing this is one more vector. This I call it as E2 bar. E2 bar. Or if I could show, I will show one more vector in the red color. So this is what is one more vector, which I call it as E2 bar. This one is towards negative charge. Now look at these two vectors now. We have two vectors which are parallel to each other. Now remember friends, this negative charge that is given in the data, we will use up to this point, that is to write the vectors. Afterwards, we never carry that negative sign into the calculation. So in the case of electric field examples, underline this point forever. In the case of electric field examples, negative charge given to the negative sign given to the charge is used till we are writing these vectors. After that, negative sign never carries into the calculation, is the point, remember. So this is now two vectors parallel, therefore I am now writing net intensity. Alright, whenever we find two or more, we write net intensity. Net intensity is equal to E1 plus E2. Why E1 plus E2? You can write that as a data because E1 bar parallel to E2 bar. So this is our result. Now we will simply write. Remember, this positive sign is not algebraic addition that we got. Here we have got positive sign because the vectors are parallel. Supposing if the vectors were anti-parallel, yes, you will get it as E1 minus E2. Other than 0 or 180, any other angle, yes, the same root of t square plus 2 square plus 2pq cos theta you will use. Therefore, this plus or minus is only because of the vector addition, remember, and that is why the negative signs given in the data not carried into the calculation. E1 plus E2. Therefore, now what is that E1? E1 is equal to KQ1. K means, yes, 1 by 4 epsilon naught term. KQ1 by, yes, this is R squared by 4 because the distance is equidistant. Is it a midpoint? Exactly, it is there. And then what is the E2? E2 is K Q2 by, again R squared by 4. Therefore now I want the net intensity. So here only I will write it as, so what is the E net? E net is equal to, see this K R squared by 4, everything is common. Therefore I will take it as 4 K R squared, and you have Q1 plus Q2. So this is our final substitution, which we are getting an answer easily. Now remember, in the final step, as I have told you, here Q1 plus Q2 is there, or if it was E1 minus E2, you will get Q1 minus Q2. But there you should never use the additive property. Additive property should not be used in the calculation of net intensities because it is only the vector addition that we have to use. So what is the final answer? That's last part. Actually, I don't want to do that. Actually, we have never done. We never did such simplifications in the classroom, right? One last slide. 4 times. What is the value of K? 9 into 10 rise 9. R square value. How much we got this R? R is given to be 12 centimeter. So 12 centimeter squared, 144. And now see, remember it is centimeter. Centimeter converted into meter. Therefore it is 10 rise minus 4. And then you have Q1 plus Q2 substitution. Q1 is going to be 5 nanocoulomb. Q2 is going to be minus 10 nanocoulomb. One more time, this negative sign will not be carried into the calculation. No additive property, only vector addition we have taken. Therefore, Q1 plus Q2 is 5 plus 10. Both are nano. Therefore, this 10 rise minus 9. So that's what is the final answer. Okay? You got your answer now. This is 10 rise 9. 10 rise minus 9. Everything is gone. So this is 9 ones and 9 6. Right? 9 1 ja and then 9 6 ja. Right? So this is 4 by 16 into this 10 rise 4 is there. Right? This 10 rise minus 4. Right? Therefore, the final answer is 1 by 4. 1 by 4 means 0.25 into 10 rise 4. Since it is an electric field, I will take the units as Newton per Coulomb or volt per meter. And in right multiples also you can write. This I will write it as, suppose if I do 2.5, then it becomes 10 cube. Then I will write as kilovolt per meter. So afterwards, especially in competitive examinations with ABCD options given, finding that right submultiple is an important thing. The same answer will be given in some multiples. There you need to take many things. Suppose if I say 25. If I do it as 25, what will be the submultiple? Or if I have to write it in megavolt 10 by 6, what will be the change? So all such things you will take. Now, what is that is important? Take from this example. More than one charge, whether 2 or 3 or any number given, and asked to find the net intensity. Yes, we have to draw vectors and add vectors, and hence it is the vector addition negative sign given will not be carried into the data. There, for all such examples, no additive property, the only magnitude is to be substituted. So I had taken the case of 2-point charges and finding the net intensity. Now let us see in the same case of 2-point charges with the concept, with an additional concept. Look at that example. As a 2-point charges, plus 3 microcoulomb and plus 12 microcoulomb, they are 15 centimeter apart. The question is, find the location of null point. Now, this concept of null point or neutral point, it is not something new. In fact, it is the same concept of equilibrium that we have discussed earlier. Remember, we did the case of equilibrium. There also the stable equilibrium and unstable equilibrium in the case of examples based on Coulombic force. What is meant by equilibrium? Yes, net force being zero and the charge remains at rest. A charge acted by 2 or more number of forces such that net force is 0, then that state is what is called a state of equilibrium. Now, that point at which the net force is 0 is what is called as null point or neutral point. Got it? Therefore, null point or neutral point is the same case of the equilibrium. Now the point is that how to locate that point is a simple common sense. After that, you will write the same case of writing 2 forces earlier. Here we write it as writing 2 intensities, or if 3 charges are given, 3 intensities we will write. Remember, intensity expression is also nothing but Coulombic force only. A small improvisation is there. Is it not? Now look at this data. Now data says both are like charges. The system of like charges are given. I call this charge Q1 and this charge is Q2. System of like charges, and of course, as usual, this is the line joining that we are taking. Now for the null point or neutral point, otherwise the state of equilibrium, we need, yes, at least 2 forces equal and opposite. So we should now get the concept of that opposite vectors. Where do we get that? Is what is our simple examination. Supposing if I consider a point over here, suppose if I consider some point P and it is said to be both are like both positive or both negative. Now at this point P, the intensity due to Q1 is E1, and how do you write that? Since it is a positive charge, you will write it as, yes, away from positive charge, E1 bar. And similarly Q2 is also a positive charge, and therefore at this point P, the intensity E2 bar due to Q2 bar is, again you will write it as E2 bar, which is away from positive charge. And that is where that positive negative sign of the charge is the critical and the most essential point in these examples of electric field. Okay? Therefore now here you will see that E1 bar and E2 bar are parallel vectors, no question of zero resultant, no chance. Similarly, if you consider even a point other side, here also you will find E1 bar and E2 bar will be parallel. So both charges, when they are like, that is both positive or both negative, any point outside the combination, you will see the E1 bar and E2 bar are parallel, no question of null point. Therefore now, remove this. Outside the combination, it is not possible. Therefore now let us come within the combination, in between Q1 and Q2. Supposing Q1 and Q2 are 2 point charges and the distance between them is R. Now supposing somewhere over here this point P I have taken, don't take it as exactly midpoint, no, some point, let me tell you. Supposing if I say, let me write, no confusion, this is what is P, and if you call these positions as A and B as usual, the positions of Q1 and Q2, if P is the point, I have taken in between the two charges. Then what about the vectors? This is a positive charge. Q1 is a positive charge, therefore it is away from positive charge. This is what is E1 bar. Now if I have to write it another field, positive charge Q2, and the field E2 is away from positive charge, this time now, yes, you will see the vectors are anti-parallel. Since vectors are anti-parallel, in the case their magnitude becomes 0, yes, net intensity is 0. That net intensity 0 net intensity point is what is called as null point or neutral point. Net intensity 0 means any charge placed at that point. Remember, any charge, whether it is positive charge or negative charge, whether it is a higher charge with higher magnitude or smaller magnitude, nothing to do with the magnitudes or the sign, any charge placed at this point P with equal and opposite forces, otherwise now called intensities, P becomes null point. Therefore, system of like charges, such a null point, first we are getting, remember, on the line joining, system of charges, only 2 charges we have given, where we are getting the null point only on the line joining the 2 charges. Second one is not outside the combination. If it is like charges, we are getting the null point between the 2 charges. Now a small, simple mathematical expression. Supposing if this distance, the total distance I have taken it as R, and suppose this distance from Q1, distance of this null point from Q1, if I take it as some D point, D distance, then this distance becomes R minus D from the other charge. So now everything is set. P is the null point at a distance D from Q1, and R minus D distance from this charge of other plus Q2. Now what is the condition for equilibrium or condition for null point? So now I am writing at null point, yes, the 2 vectors are equal and opposite. E1 bar is equal to minus E2 bar. Negative sign saying that opposite in nature, and therefore now I am writing mod E1 bar is equal to mod E2 bar. It will use simplification. Now writing 2 intensities. Again, point charges, intensities, right? What is this E1 bar? K. E1 is due to Q1 by what is the distance from Q1 I have taken? See, D. Therefore, K is D square equal to K. Intensity E2 bar due to Q2. Therefore, K is Q2 by Yes, this distance we will now see this as r minus d, right? So this is r minus d whole square, r minus d whole square, and small simplification of course. Now it is left with, so what is that? We get kq2, I'm sorry, yes, kq2. Therefore now what you will say that q1 by q2 is equal to d by, yes, r minus d. Both are square here, right? Both are square, therefore I will take it as root. K cancels and everything. In between 1 or 2 lines in the board examination you will do. Let me not do that each and every line. Right? Now again this one you can, or else I will write it as, suppose if this is what is q2 by q1, shall I write it as r minus d by d, r minus d by d, which is nothing but r by d minus 1, right? So q2 by q1 under root is equal to r by d minus 1. So one other side simplification, let me not do that, one or at least one line in between you do. Now what will be expression for d? So d is equal to, this term is there, r upon, this is under root, yes, under root q2 by q1 minus 1, therefore it becomes plus 1. This is what is the expression that you got. Now remember, this is not the final answer, because this r by root of q2 by q1 plus 1 is, remember, the distance d is taken from q1, is it not? Therefore r by root of q2 by q1 plus 1 from q1 is the answer. From q1 is the answer. Now what is the meaning of q1? q1 does not mean the first charge that is given. See, there the order is 3 microcoulomb and 12 microcoulomb it is said. Therefore 3 microcoulomb is q1, 12 microcoulomb is q2, not like that. Now here what is the meaning of q1? q1 is the charge from which we are calculating the distance of null point. Suppose if I am calculating the distance from 3 microcoulomb, I will take 3 microcoulomb as q1. If I am calculating the distance of null point from 12 microcoulomb, then 12 microcoulomb becomes q1. That is what is the meaning. So this is d r by under root q2 by q1 plus 1 from q1 is what is the answer. So substitution and answer is already there. R is going to be 15 centimeter, yes, 15 centimeter q2 by q1. Now it is your choice from where you want to find the distance. Supposing if I am finding the distance from smaller charge, that is from 3 microcoulomb, then you will write it as 12 microcoulomb by 3 microcoulomb, everything micro 10 raised minus 6, yes, cancel, root is there, and then of course plus 1. So this is 15 by 2 under root 4, therefore this is 3, this is 5 centimeter. 5 centimeter from, remember, see from q1 I have written as 3 microcoulomb. If 5 centimeter is the answer, no, this is 5 centimeter from plus 3 microcoulomb is the answer. If it is plus 5 microcoulomb, then from this charge of 12 microcoulomb, how much you get? Yes, you will get it as 10 centimeter, because total distance is going to be. Therefore now this is another answer is 5 centimeter from 3 microcoulomb or 10 centimeter from plus 12 microcoulomb. Now after writing the answer, now let us come to most important points, which will be our observation and our understanding. Remember, these are all memories. This is where you use all your observation and logic. The first point is that system of like charges given, we get the null point between the two charges on the line joining. Null point always, if at all we are getting system of two charges on the line joining. Second point is, if system of like charge is there, it is in between the two charges. And now what is number 3? What is that you can observe? Look at these distances. It is 5 centimeter from 3 microcoulomb or 10 centimeter from the other charge which is higher, 12 microcoulomb. So null point is always closer to smaller charge. I repeat, the third observation is the null point is always closer to smaller charge, farther, farther to higher charge, mean large charge whichever is there. So smaller charge null point is always closer. So this is what is our take. This is now I have given the case of two like charges and separation. Supposing in the same example I just change the symbols. That is, I take system of unlike charges. Then what will be the answer? Now let us see that here. Supposing if I do it as this minus 12 microcoulomb, if I give this number, minus 12 microcoulomb, I give this number, say 15 centimeters, what will be the distance of null point, right? Now one more time, let me write. Actually, now it is your turn to write those vectors. Where do we get that anti-parallel vectors is an important thing, right? Where do we get anti-parallel vectors is an important thing. Now it is the case of again unlike charges, right? So supposing this is what is plus q1 and this is what is minus q2. Yes, unlike charges are now given. And of course, as usual, the line joining the two charges. Earlier we have examined at the three different locations. Here also let us do the same. Supposing if I consider a point in between the two charges. Remember again I am doing it for a point on the line joining only. This time if I consider this as between, then you see what happened. Plus q1, the field is even and away from positive charge, and this is minus q2, therefore this will be again towards negative charge. For such case, now you got both E1 bar and E2 bar parallel vectors. Parallel vectors means no question of null point. Therefore, in the case of system of unlike charges, we don't get a null point, a neutral point in between the two charges. No, right? Now let us examine outside the combination. When it is the case of outside the combination, now again you have two chances. Either it is towards your left of q1 or right of q2. Now where to find that? Because to the left of q1, E1 bar, E2 bar, you will get anti-parallel, opposite, yes. So even to the right of q2 also at any point on the line joining, you will get E1 bar and E2 bar in opposite directions. Right. But where do we get that null point? For that third observation that we did earlier, in the case of a null point, the null point is always closer to weaker charge. Weaker charge, stronger charge, if I call them, it is closer to weaker charge. What is meant by weaker charge? The magnitude lesser. Supposing if it is earlier plus 3 microcoulomb and plus 12 microcoulomb, yes, we call it as weaker. This is weaker and this one is stronger. Right? Supposing if it is plus 3 and minus 12 as given in our diagram, then also plus 3 microcoulomb is weaker. Now don't use your mathematics and say, sir, minus 12 is less than plus 3. No, it is not like that. Only the magnitude that you have to take. Right? So in such cases, whichever got higher magnitude, you will call it as stronger charge, stronger charge, and the other becomes weaker charge. Now tell me that the null point is always closer to weaker charge. Therefore, now in the given example, if I take this as 3 microcoulomb which is positive and this is 12 microcoulomb which is negative, the same example, now this time you will take the null point towards the left of this 3 microcoulomb. Nearer to smaller charge is the most important thing to be remembered. Therefore, now here I take this point as P, which is a null point. Now supposing again this distance from Q1, if the distance of null point is B from Q1, the distance from Q2 will be Yes, R minus D. Remember, earlier it was D from Q1, R minus D from the other charge because it was in between. Now this time, from Q1, if it is D, from the other side it will be R plus D. I'm sorry. So this is what is R plus D becomes. So R plus D distance. Now again, the same rule. What is that? E1 is equal to E2, and that is mod E1 bar is equal to mod E2 bar. Again, K Q1 by the distance from Q1 is taken to be D. Therefore, D squared is equal to K due to other charge Q2 is equal to R plus D whole square. R plus D whole square, such that the simplification again will give you. This is what is Q2 by Q1 under root is equal to, this time will get R plus D by D. So therefore, what is the small change that you will find? This distance D is equal to, yes, the original distance between Q1 and Q2 by under root Q2 by Q1. Now this time, earlier we got plus 1, is it not? Now here you will get plus, the other side it goes. Therefore, this becomes minus 1. Minus 1, of course, as usual, it is from Q1. And what is the meaning of Q1 I have taken? Remember, Q1 is the charge from which we are calculating the distance of null point. Therefore, in the substitution, you will find that I will do it in two ways. D is equal to original distance 15 centimeter by, supposing if I write it as 12 microcoulomb by 3 microcoulomb, and this is minus 1, this under root 4 becomes 2 minus 1. So this is 15 centimeter from 3 microcoulomb, which is positive, or else supposing is the same, calculate D is equal to, yes, 15 by, if I write it as 3 by 12, then the distance is from 12 microcoulomb, like this. In the case of field examinations or other examinations, this is what is a simple thing that is to be implemented. And again, minus 1, don't remember, right? This is what is minus 1. So you will get this as 15, this becomes 1 by 2. 1 by 2 minus 1, of course you will get it as minus 1 by 2, you will find. And this negative sign will have the significance. So this is what is 30 centimeter from minus 12 microcoulomb, because I have when this is minus 12 microcoulomb. So what is the meaning of that? One understand. Earlier 15 centimeter from 3 microcoulomb, now this time 30 centimeter from minus 12 microcoulomb. So where is the point? Use the same point again and again. I am telling you, it is always closer to weaker charge. If this is what is 3 microcoulomb, yes, you got this null point over here. You got this null point over here, which is 15 centimeter. Therefore, from the other side, if you take that is Q2, it will be 15 plus 15, because already there is 15 and one more 15, 30 centimeters, like that. Therefore, if I have to wrap it out as a single expression, what you will write it in your notebook as a special note is, in the case of two charges, 2 point charges, in the case of 2 point charges Q1 and Q2, separation between them is supposing R. They can be either like charges or unlike charges. Now we write the distance of null point. Distance of null point is, I am using some symbols here, but symbols should never be your confusion. You write your own symbols, it doesn't matter. But when you are using a symbol, what is the meaning with which you are using that symbol? Be clear about that. Now I am writing D is equal to R upon, yes, under root Q2 by Q1, right? We have now plus R minus 1. We have two cases left. If it is plus or minus 1, this is from Q1 is the most important thing. Now I told you what is Q1, not with respect to order, but it is the charge from which you are finding the distance of null point referred as Q1, such that in this example, when do we use positive sign and when do we use negative sign is an important, not a memory, it's a logic, you see. Earlier we said in between. When do we get? Between the two charges. Between the two charges means D less than R you will get. Therefore, that is why you will get plus 1. So, for Q1, Q2, yes, greater than 0. That is what I mean by like charges. Both positive, both negative. And here it is Q1, Q2 less than 0. That is unlike charges. That is unlike charges. Remember, whether it is unlike charges also, I never said that it is closer to positive or closer to negative. I have not used such terminology. Whereas I told you that it is always closer to weaker charge. Only that magnitude, leaving that sign aside. This is what is our important. This will be your special notes. When you write it in the notes, you will just write it and you will practice that, so that for quick solutions in your other examinations, it will be helpful. Is it not? Now this is what is the case of neutral point or null point and only 2 point charges. Now let us see some more interesting examples. Other example, we have seen the case a point on the line joining the two charges as collinear. All the points were collinear, and now let me take one more example with the case of a coplanar point. For that, the example is like this: 2 point charges. I have taken as positive and negative. Plus 3 microcoulomb and minus 3 microcoulomb placed at 2 corners of AB of an equilateral triangle ABC, and the side is 10 centimeter. Find the net intensity at the vertex C is the given. So now first, what is that figure? The geometry is an equilateral triangle. The triangle is an equilateral triangle. Remember, I call it as A, B and C. A, B and C. So that here the charge at A is, at the site of A is Q1, given to be positive, and at the site of B is given to be another charge which is Q2, a negative charge, and this is what is the vertex C. Remember, this is a negative charge and this is a positive charge. And I have told you, whenever you are dealing with examples of intensity, net intensity of electric field, always that sign carries an important, because we have to draw the vectors where that sign is the key point, right? So now suppose, let me write L is the side of each of this triangle, and of course all angles here will be 60 degrees at the vertex. Now first let us write the intensities again at C. When you say, I have told you, whenever it is net intensity, draw vectors and add vectors, no question of scalars, always vectors. Now at the point C, what do you observe? What do you observe? For that I am doing one more geometry with vectors. I am now showing this is what is earlier ABC, this is what is positive charge, and this is what is negative charge, and the point of observation. Now plus Q1, the intensity is away. Plus Q1, the intensity is away. This is what is E1 bar, and negative charge it is always towards. So this is what is E2 bar, and this is what is the angle between the two vectors, which becomes now this theta is equal to 120 degrees. Now you see, I need not be equal. I have given such an example which is 3 microcoulomb and minus 3 microcoulomb, but they can be unequal magnitude also. For a simple mathematical simplification, I have given you this as equal. Now there are two vectors and angle between them. Yes, writing the magnitudes and using that root of p square plus 2 square plus 2p cos theta, right? Therefore now let me write those magnitudes. What is now E1 bar magnitude is equal to E2 bar, both are same in magnitude. Why? Same magnitude and same distance. Only difference is, one is away from the charge, the other is towards the charge. Yes, there are two different vectors, but magnitude is same. Mod E1 bar is equal to E2 bar is equal to, supposing I call it as capital E. What is the capital E value? Capital E is equal to KQ by L square. KQ by L square Q, because both are of same magnitude, and that is why. If Q1 and Q2 are different, definitely mod E1 bar, mod E2 bar will be different. They will calculate separately, but here I given them to be equal. KQ by L square. And now what is the angle between them? Yes, angle between E1 bar and E2 bar is 120 degrees. Yeah? Why? Because it is again exterior angle for equilateral angle. Is it not? 120 degrees. Simple geometry, and this knowledge is of course from high school. Exterior angle is equal to sum of opposite interior angles, like that. Therefore now I am writing as net intensity. So net intensity is root of P square plus Q square, that is both are same in magnitude, plus 2P Q2 E square, and this is cos 120, which is minus 1 by 2. Right? 2 gets cancelled, therefore it is E square minus E square. And of course the very simple answer finally is E net is equal to E only. Right? E net is equal to E only, and what is that value? We will have taken as KQ by L square. Now substitution and simplification. Your job, right? So this is 9 times 10 raised 9, the value of K. This Q is given to be, of course, 3 micro, right? So this is 3 micro submultiples. I don't know how many number of times I keep repeating this, but still every time I tell you, because this is what is one such simple, you can call it oversight or mistake committed by most of the students. Multiples, submultiples, be very cautious, right? Micro, and the distance given to be just 10 centimeters side and side. Again it is 10 centimeter square, therefore it is 10 by minus 2. So this will be your answer, you will do it anyway. Therefore in the case of system of charges, point of observation is collinear was earlier case. Now here in this case we have taken again system of charges. Only 2 charges I have taken to begin with. But the point of observation was not collinear. You see, it was the other point. That is, the point C was a coplanar point. So there also, whether it is collinear points or coplanar points, the rule is always the same. Draw vectors, add vectors. In the case of collinear, you will get E1 bar and E2 bar either parallel or anti-parallel. In the case of like coplanar, there you will get the other angles, other than 0, other than 180, other angles that you will get. And most important point, please do remember net intensity examples. Whenever we are using that vector addition and finally you have Q1 plus Q2 or Q1 minus Q2, it is not the additive property of the charge. That negative sign was used only up to the point of drawing the vector. After that, the negative sign of the charge will never carry into the calculations. It's an important thing. Mentioning third time or fourth time. Don't do or don't commit such mistake, right? So more examples and interesting examples will continue in the next class. Eat well, sleep well, prepare well. Good day.